66 million years ago, Earth experienced one of the most devastating extinctions in planetary history. Dinosaurs, who had dominated for over 150 million years, suddenly vanished from the Earth. For decades, the story was told simply. An asteroid struck. Chaos followed, dinosaurs were wiped away. But modern science reveals a far more complex, layered, and shocking truth behind this cataclysmic event. The late Cretaceous world was lush, diverse, and filled with remarkable creatures across land, sea, and sky. Herds of Triceratops grazed on flowering plants, while Tyrannosaurus stalked wetlands with terrifying precision. Hadrosaurs lived in great numbers, filling riversides with calls echoing like prehistoric choirs across vast plains. Above, pterosaurs soared with wingspans larger than small planes, sharing skies with primitive birds adapting quickly. The oceans were equally magnificent, filled with ammonites, mosasaurs, giant turtles, and countless smaller creatures. These ecosystems thrived in delicate balance, but beneath abundance lay stresses threatening their stability. Sea levels rose and fell, reshaping coastlines and pushing species into new, unstable environments. Climate shifts produced unstable conditions, with periods of drought alternating with violent storms across continents. Volcanic activity in what is now India created vast eruptions known as the Deccan Traps. These eruptions poured immense lava flows across land, releasing dangerous gases into the global atmosphere. Carbon dioxide increased dramatically, warming the climate while sulfur dioxide poisoned rainfall with acid rain. Forests withered, soils leached nutrients, and species began struggling long before the asteroid ever appeared. Then came the asteroid, a 10-kilometer-wide rock hurtling toward Earth at unimaginable speed. It struck the shallow seas of the Yucatan Peninsula with force beyond billions of nuclear weapons. The explosion vaporized everything nearby, igniting firestorms across continents as molten debris rained from skies. Tsunamis higher than skyscrapers thundered across oceans, drowning coastlines and shattering fragile marine ecosystems. Dust, soot, and vaporized rock entered the stratosphere, forming a shroud that blocked incoming sunlight. Global temperatures plummeted, and photosynthesis collapsed as plants died from lack of life-giving light. Herbivores starved, leaving predators like Tyrannosaurus rex without food, triggering cascades of death across continents. The asteroid's impact was not just local destruction, but a global tipping point into darkness. Yet the asteroid alone may not fully explain this world-shattering extinction. The Deccan Traps had already poured millions of cubic kilometers of lava across Earth's surface. For hundreds of thousands of years, volcanic eruptions spewed gases, destabilizing global climate cycles. Carbon dioxide triggered intense greenhouse warming, while sulfur dioxide caused episodes of chilling volcanic winters. Some scientists argue these eruptions weakened ecosystems long before the asteroid arrived. Animals already strained by unstable climates were less able to survive an additional catastrophe. The asteroid may have been the final blow, striking a world already trembling under volcanic stress. The truth appears to be a combination, where multiple disasters converged into one extinction storm. The chain of extinction was brutal, systematic, and unavoidable once collapse began. Plants died first, their growth impossible without sunlight and stable climate conditions. Forests disappeared, leaving barren landscapes where once vibrant ecosystems thrived with diversity. Herbivores like Triceratops and Hadrosaurs starved within weeks, collapsing populations at alarming rates. With herbivores gone, predators fell soon after, unable to find enough prey to survive. Tyrannosaurus rex, apex predator of North America, succumbed as food supplies dwindled rapidly. In oceans, plankton collapsed without sunlight, destroying the base of marine food webs. Ammonites, mosasaurs, and plesiosaurs soon vanished, leaving seas emptied of their most dominant creatures. Skies were no refuge either. as pterosaurs completely disappeared from the fossil record. Only small bird lineages endured, their survival linked to unique adaptations in diet and behavior. Birds with beaks capable of cracking seeds endured because seeds remained long after plants perished. This minor advantage ensured survival when nearly every other aerial lineage was extinguished. Survival favored creatures small, adaptable, and resourceful during this planetary apocalypse. Mammals burrowed underground, shielding themselves from temperature extremes and toxic atmospheric conditions. Crocodiles survived in rivers, feeding opportunistically and withstanding harsh environments remarkably well. Insects endured, maintaining ecological functions and recycling dead organic matter during widespread devastation. These survivors became architects of the new world rising from extinction's ashes. Mammals diversified into countless forms, evolving into predators, grazers, and eventually intelligent tool users. Birds expanded into skies, carrying dinosaur heritage into new evolutionary directions. Even crocodiles thrived, maintaining their ancient ambush strategy relatively unchanged across millions of years. The extinction was not simply destruction but also transformation on a planetary scale. The removal of dinosaurs opened ecological space for mammals to expand and dominate. Without this catastrophe, humans likely would never have evolved at all. The extinction of one group paved the path for another to rise. The legacy of this event is both haunting and instructive for us today. It demonstrates the fragility of ecosystems and how quickly balance can unravel under stress. It also reveals how multiple disasters often combine into overwhelming extinction cascades. The asteroid alone was deadly, but volcanism ensured ecosystems were already weakened. Modern research suggests extinction was not instantaneous, but unfolded in stages. Initial fires and tsunamis killed countless individuals directly after the impact. The global darkness and starvation took months to years to collapse ecosystems entirely. Recovery required millions of years before ecosystems regained complexity and stability. To imagine that world is to imagine firestorms raging, skies darkening, and oceans turning sour. It is to watch herds of giants collapse while burrowing mammals quietly endured unseen. It is to see pterosaurs vanish while tiny birds clung desperately to existence. It is to witness Earth's transformation under forces far beyond creaturely control. The death of the dinosaurs reminds us chance events shape the course of evolution. If the asteroid had missed, dinosaurs may still roam Earth, and mammals may remain obscure. Our very existence is tied to their absence, a debt written in deep time. What really killed the dinosaurs is not one story, but many woven into catastrophe. Stay curious, because the extinction of the dinosaurs still teaches lessons for our fragile future. It shows how climate instability, atmospheric change, and cascading collapse can alter life globally. And it warns us that ecosystems, however strong, can unravel far quicker than we expect. The story of their end is tragic, complex, and deeply human in its consequences.